Hi, I'm a member of the Teen Advisory Board of the Howard County Library System, and today I'm going to go over two other built-in data structures, tuples and sets. And I'm also partnered with the chspyoneers, a school-based computer science club whose mission is to spread our passion for coding and also inspire others to code. So today we will be discussing what tuples and sets are, how they are different from other built-in data structures, and then also some useful methods when using these data structures. For today's video, all of my screenshots will be from the useful in-browser IDE, Repl.it. And so without further ado, let's get started. So let's first start with tuples. So tuples are very similar to lists, but there are also a few key differences between them. So first of all, tuples are symbolized by parentheses, while lists are symbolized by square brackets. So that means anything you want to put inside of a tuple, you have to put inside of parentheses, and then you also have to separate the objects by commas, just like you do lists. And also, like lists, tuples store their items in a list-like structure. And all of the objects inside of this list-like structure are ordered. So what this means is that the order of the items inside of this data structure are saved, and then each object has its own individual index. And what's important to remember is that indexing always starts at 0. So what this means is that each time I recall a tuple, for example, I just print out the tuple, the order of the objects will always remain the same unless I change it in the code. And so since each object is indexed, I can always just refer to a specific object by its index number. So in this example, we have a tuple of colors. And in this tuple, which is inside of these parentheses, we have the strings red, blue, and green, all separated by commas. And if I wanted to refer to this specific blue string, then I would just have to use its index number, which is 1, because red is 0 and then blue is 1. And so if I just printed out this item from the tuple, we get the blue string, which is exactly what we were looking for. However, tuples are unchangeable. So what this means is that unlike lists, we cannot add, remove, or change any of the items in the tuple. So if I try to, for example, like a list, refer to the list or the name of the tuple and put inside of the square brackets the index number I'm trying to change, and then put the new object I'm trying to change that specific index to, I'll receive an error because tuples are unalterable. And so what are some possible uses of tuples over lists, you may wonder? Well, you might use tuples over lists in scenarios when you already know all of the items you want to put in that tuple, the order they need to be in, and you also know that you don't need to change it at all. So for example, a data structure containing the days of the week would be a perfect example of using tuples over lists, because we already know the days of the week, so we already know all of the items that we're going to put inside of this data structure. We already know the order, and then we already know we don't have to change it because the days of the week remain constant throughout. So now let's move on to sets. So sets, as you can see, unlike tuples or lists, are symbolized by these curly brackets. And inside of sets, all of the items are unordered and unindexed. So what this means is that since the items don't have an index, you can't refer to them by a specific index number. So for example, if we have this set of colors, colors 2, and inside the set we have the strings yellow, orange, and purple, I won't be able to try to refer to a specific index because none of the items have an index, although it may appear as such in the code. And in addition, these items are not ordered, which is a reason for why they don't have an index. So each time I call this set or try to print it out, the items will appear in a different order each time. As you can see in these examples, each time I call it, it appears in a different order. Another key difference between sets and tuples and lists is that you cannot change items by a specific index number because there are no indexes. And so what this means is that although orange may appear in the first index, like we discussed, it is not really in the first index because it is not indexed at all. So we can't specifically say that we want this object in this position to change. But however, you can just add and remove items through methods, and we'll discuss those methods later on in the video. In addition, sets do not allow duplicates. So if I was to add on, for example, an extra orange string to the end of this set, whenever I print out the set, it'll only show one orange because it'll only keep one of them because it doesn't allow duplicates. And now let's move on to some useful methods for both tuples and sets. So for tuples, there are really only two useful methods we can use, the count and index methods. The count method returns the number of times an object occurs within a tuple. So as we can see in this example, we have the vegetables tuple. And inside this tuple, we have the strings carrot, corn, pepper, and then corn again. And so if we use the count method to see how many times the string corn appears within this tuple, and then we print out the result, we get 2. And so when we look back at our original tuple, we see that in fact corn does appear twice inside of this vegetables tuple. And so the index method returns the index of the first occurrence of a specified item. And if it does not find the specified item, it'll throw an error. So what this means is that it will just return the index or the position of the first occurrence of the object. And so if it occurs multiple times, it'll just return the first time it occurs in the tuple. And so in this example, we just use the index method to try and see where corn appears first. And we get the results of the index number 1. And when we look back at our original tuple, we see that in fact corn does appear at the index 1 first. And now let's move on to some set methods. There are a couple of useful methods we can use with sets, such as the add, clear, and discard methods. So let's first start with the add method. So let's say, for example, we have this set of flowers, in which we have the strings daisy, lavender, rose, and orchid. So the add method simply just adds the specified item into a list. So if I wanted to add this string lily into the flowers set, all I would do is just run this code right here, and then if I printed out the resulting flower set, this is what I would get. I would get the same set as before with just the lily string inserted into it. And so the clear method essentially just removes all items of the set. So when we run this flowers.clear and then we do print flowers, we get that we just have this empty set object. And so this just means that it's an empty set data structure without any elements inside. And finally, we have this discard method. So the discard method essentially just removes the specified item from the list, but only if it exists. So if I tried to discard the string daisy using this line of code, and then printed out the resulting set, this is what I would get. I would get rose, lavender, and orchid without the daisy string because it's being removed. However, if I put something else into this, for example, if I tried to discard the sunflower string, it essentially will just return the same string because it can't remove something that's not there. There are also a couple of other useful set methods we can use that involve 2 or more sets. The first of such is the difference method. The difference method returns a set of all of the items that exist only in the first set, but not in the other sets. So, just as the previous examples, we have this same set of flowers. And now we have a second set of flowers, flowers 2, with the strings daisy, sunflower, rose, and lily. In this example, we are printing out the resulting set of flowers.difference and then flowers2. So flowers is the first set and then flowers2 is the second set, which is inside the parentheses. And so what this will do is that it will return all the items that exist only in this flowers set. And so when we run this code, we get the set lavender and orchid. And so what this means is that lavender and orchid exist only in the flower set and not in the rest of the sets, which is just flowers too. And so the intersection method returns all of the items that exist in all of the specified sets. So for this method, it does not really matter which set is first or second. So when we do this code, print flowers.intersection flowers2, it will just return all of the items that exist in all of these specified sets. So the items that are in common between the sets. And so when we run this code, we get the strings Daisy and Rose. And so when we look back at our original sets, we do see that Daisy and Rose are the only items that are shared between the two sets. And the final fairly useful methods for sets is the union method, which essentially just returns a set that contains all of the items from the specified sets while excluding duplicates. So if we use the same sets from the previous examples, flowers and flowers too, and then we just wanted to combine all of the items into one set, excluding the duplicates, we would use this method. And so when we run this flowers.union flowers2, and then we print out the resulting set, we get this set, which contains all of these strings, excluding the duplicates. So we don't see Daisy twice, or we don't see Rose twice. And so that's basically it. And now let's finish this video with some practice problems. So let's first start with tuples. So here we have a tuple of numbers and then 3 blocks of code. So please pause the video and try and figure out the output to these 3 blocks of code. And now let's discuss the answers. So for question number 1, we are just printing out the object that is in the first index of the numbers tuple, which is 13. For number 2, we get an error because when we try to change the tuple, it throws an error because tuples are unchangeable. And for number 3, we are just simply printing out the index of the first occurrence of the number 12 in the numbers tuple. And so when we look at the original tuple, we see that 12 is in the second index, and that is the first occurrence in the numbers tuple. And so now let's move on to some practice problems with sets. So here we have 2 sets, cars and cars 2. And so please pause the video and try and figure out the output for these 4 lines of code. So now let's discuss the answers for these 4 practice problems. So for the first question, we get an error, and this is because objects in sets are unordered and unindexed, so we cannot refer to a specific object by its index. For number 2, we also get an error, and this is for the same exact reason, because the objects within a set are unordered and unindexed, so we can't refer to a specific object by index. For number 3, we get a set containing the strings coupe, sedan, hatchback, minivan, and sports car. And this is because the discard method only discards the string from the set only if it exists within the set. And as we can see, the string convertible does not exist within the original set, which is why nothing is discarded from this set. And for number 4, we get a set containing the strings convertible and SUV. And so essentially what is happening in this 4th question is that we are trying to see which objects or strings exist in the cars 2 set that do not exist in the rest of the sets, which is just cars. And so when we look back at the original sets, we see that these strings convertible and SUV exist, but those strings do not exist within the cars set. If you have any questions, please feel free to email the CHS Pioneers email, which is chspyoneers@gmail.com. Also, you can use the online useful resource of w3schools.com, which contains many useful articles and examples on tuples and sets and all other things related to Python. Thanks for watching.